All right, so let's talk about Lewis dot diagrams. And we're going to start with the basic of just drawing the Lewis dot diagram for atoms, and then we'll proceed on to drawing Lewis dot diagrams for ions. Okay, so when you have a Lewis dot diagram, you're only talking about the outer ring or the valence electrons. So the outer ring holds the electrons that are used for bonding in a chemical reaction. And we know how to figure out the valence electron. It corresponds to the number on the group. So it depends on the periodic table, whether they're categorized as the A or the B elements. But we discussed in our classes before that it is on the tall columns on the periodic table. It's the Roman number at the end of each of the tall columns. So these electrons are found only in the S and P orbitals. That's why it's the tall columns only, because if you remember from our quantum address, the short columns are the D, and then the bottom of the periodic table is the F. So we're only going to be talking about the electrons that are found in the S and P orbitals. Those are the valence electrons. And we already know that the valence electrons determines the chemical properties of the element. So we've discussed that having the same number of valence electrons gets an element grouped into their family. Okay, so this is our periodic table, and the number that I'm referring to that tells you the valence electrons is the number that is right after the regular numeric value. It's the Roman number. So this one says a Roman number 1, that has a Roman number 2, that has a Roman number 3, 4, 5, 6, 7, and 8. Remember, disclaimer, helium does not have 8 valence electrons because it only has 2. So even though it's in the 8 column, remember, don't answer that it has 8 valence electrons. It only has 2 valence electrons because it only has 2 electrons total. All right, so when we're looking, we see that row number 1 has 1 valence electron, row number 2 has 2 valence electrons, etc. So row 3 has 3, and this PowerPoint is circling the Roman number value for each of that: 4, 5, 6, 7, and 8. So that's where we're figuring out the valence electrons. And don't forget, helium only has 2. All right, so this is how we apply the Lewis dot structure. This structure is not the same as it was when I was a kid. However, it's the one that corresponds with your textbook, so that's the one we're going to use. But I will let you know, if you try to Google the answer out, you might get the wrong answer. So be careful that you are following the procedure that I am teaching you. Don't try to Google out your answers, or you may indeed get the wrong answer. We're going to do the Lewis dot structure according to your current textbook. All right, so when you only have 1 electron, it goes here in the 1 spot. And if you have 2 of electrons, it's going to go in the 1 spot and the 2 spot, which are across from each other at east and west. Okay. When you have 3 valence electrons, you come back up to the top. And when you have 4 valence electrons, you're then at the bottom at north and south. Okay. So you're going to be going on the right side of your structure, then the left, then the top, and then the bottom, and then the valence electrons fill in counterclockwise. So when you get 5, it's up there at the top, 6, 7, and 8. Okay, so at first you go across from each other, starting on the right-hand side, then the left-hand side, then north, then south, then back up to the top, and counterclockwise. That's the order in which we are filling in our Lewis dot structure. Okay, so the charge on the thing that we're talking about now is 0, because remember, atoms by definition are neutral. So in this beginning set of slides, we're only talking about atoms. All right, so what does argons look like? You first have to go look to see how many valence electrons argon has. Argon has 8 valence electrons because it's in the noble gas column. So you'll be applying 1, 2, 3, 4, 5, 6, 7, 8. This is what the Lewis structure for an argon atom would look like. It's an atom, so its charge is 0. So do sulfur. Pause the video and see if you can put in the valence electrons for a Lewis structure for sulfur. Pause the video and return to see the correct answer. Okay, so sulfur has 6 valence electrons. They would go 1, 2, 3, 4, 5, 6. 6 valence electrons. It's an atom, so its charge is 0. Carbon. Pause the video and make a Lewis dot diagram for carbon's valence electrons. Pause the video. Welcome back. 1, 2, 3, 4. Carbon has 4 valence electrons. Its charge is 0 because it's an atom. Lithium. Pause the video. It only has 1 valence electron. Magnesium. It has 2 valence electrons. The octet rule says when forming compounds, atoms lose or gain electrons in order to reach the noble gas configuration. So remember, when we create an ion, we are going to get to our closest noble gases configuration. So when an atom gains electrons, the valence shell will then have a full outermost complete full ring. So it's going to be to its closest noble gas. Most of the time, the closest noble gas is going to have 8 valence electrons. Remember, the exception is if your closest noble gas is helium, you will only have 2 valence electrons. So when an atom loses electrons, it drops down to the inner shell that has its full number of electrons, or it may go up to the outer shell that is the closest noble gas forward from it. So either way, I'm going to have the valence electrons of my closest noble gas. So what will sulfur do? Find sulfur on the periodic table. If you see that sulfur is number 16, so you have 2 choices for a noble gas. Will it go forward 2 and have the closest noble gas structure of argon at number 18, or will it go back 6 and be neon? It'll always do whichever is closer. And so argon, of course, is its closest noble gas. So that means it will gain 2 electrons to be sulfide. So if you're sulfide, you're going to have 2 additional electrons. Now, these are marked here as X's so that you can see the difference. And it wouldn't be X's in actuality, they'd be dots. I was just showing you the 2 electrons that I filled in, so they'd be noticeable. So valence shell is now full with 8 electrons. I knew this was an ion because the ending of its name said sulfide. It no longer said sulfur. So it has a charge of -2. So create carbide. Pause the video. See which is the closest noble gas if you are seeing that the name is carbide. And then resume the video after creating a Lewis dot structure for this particular ion. Hopefully you noticed that since it said carbide, that means that it is gaining electrons. Its closest noble gas, if it's carbide, is neon. Neon has 8 electrons, so it's going to gain 4 electrons. Once again, these X's aren't going to be X's in your final product. They'll be dots. I put them in as X's so that you can see where I was placing the additional new electrons. So its valence shell is now full with 8 electrons because it advances to neon's electron configuration. It has a charge of -4. How about if I make carbon a carbon ion. Okay, it doesn't say ion here, but this section of the PowerPoint is talking about ions. So it's going to lose 4 electrons. If it loses 4 electrons, then it's going to have the noble gas configuration of helium, which means it has 2 electrons. The helium's electrons are placed as what looks like ghost electrons, which means to let you know that you've dropped to the inner label, you don't fill in these dots. These dots are open. So when you are showing the person that you are dropping back and not proceeding forward, the valence electrons are an outside shell with an inside being open. So it's just a circle with nothing filled in. So when you proceed forward, you fill in the electrons, or you circle them with your pencil to where they make a dot. These are open. I call them ghost electrons. So this would have a charge of +4, a carbon ion. How about a lithium ion? What happens to lithium? Find lithium on the periodic table. Lithium is going to lose an electron. When it loses 1 electron, its closest noble gas is helium. So it's going to drop back to heliums and have 2 ghost electrons at east and west. It's got a charge of +1 because it lost its 1 electron. How about magnesium? Magnesium is going to lose 2 electrons. When it loses 2 electrons, it's going to drop back to the configuration of neon. So it's going to have 8 ghost electrons. 8 electrons that are just the outside circle, not filled in. It's got a charge of +2. All right, so that is Lewis dot structures for atoms and ions.